This is one start scala project. I want to show the code. So this project is all about to read the CSV file and do the validation on the CSV data and store the data into Hive table. If any error data is there, that will be stored in error table. Okay. So here I'm using different packages. So this is a driver class. Okay, this is one service class, and then this is a DO class. Okay, so actual code of business logic, right? The complete code is written in this class. Okay, so this is pure Scala code. This start Scala code. So, so here is this kind of property file will be there. So in this property file, I am how many files I want to iterate, right? Suppose I have a 5 CSV files, so I will be giving here the file count 5, okay? And which will be my error table. So I am specifying here my error table name. Here I am getting error table name. I am staging. Okay, this is any table name it can be. It will be in Hive, this error table. And basically this error table columns will be load date, load type, load date, load type, and the table name, column name, and error data. Okay. So suppose I am loading the CSV file today, and that CSV file is related to particular data type, like particular module type. So load type will come here, and load date will be the present date. Whatever date I am loading the data, and any error comes, so that data is related to some table, okay, in the Hive basically, and what is the column name and what is the actual error data, okay. So and one more alert schema, like one CSV report I am generating. Like suppose I have 100 records are there in my CSV file. I'll just tell about how it is happening. Suppose I have one CSV file name is policy hash.csv, and this policy has CSV having different column, policy ID, comma, policy name, policy date, okay, and policy duration. Okay, like this, so many columns are there. Okay, and it is having suppose 100 records. And out of this 100 records, and these are the different data types are there. Like policy name, policy ID is a integer type. Okay, policy name is a string type. Policy date is a date type. Policy duration is again integer type. How many the duration? What is the duration of the policy? Okay, so suppose in this column data is incorrect. Suppose I say in the policy ID the value is something like ABC, comma, policy name is XYZ, policy date is something, date is there, okay, something date is there, and policy duration is 5. So here if I say what data is incorrect, so here is policy ID is incorrect. Okay, so this is my error data. So out of 100 record, if I say I have 10 records are invalid record. Okay, and hello.
Yeah, I'm following that.
Yeah, you asked any question? Hello?
No, I don't have anything.
Okay, so 90, okay, so 10 records if I say I have an invalid record, and 90 records I say valid record. Okay, now what I want to do, this 90 records which are valid record, 90 records which are the valid record, I want to insert into actual Hive table. Okay, actual Hive policy table will be there. Okay, so this CSV 90 record inserted in actual height policy table, and rest 10 records will go to I staging table. That is my error table. Okay, that is error table in height. Okay, error table in height. So what will be the column name? So one is like today date is there. So load date is a one column. Load type is a one column, and I have a table name. So which table this record is invalid? So that table is a policy table. Policy table. And what is the column name? So here I will say the column name is policy ID. That is invalid. And what is the error data? That is ABC. So like this, my data will be inserted in the error table. So I will generate a one report. That report will be having these columns. So what are the columns are there? Table name, how many staging record, how many base record, how many missing record. Okay. So basically I will be how many total records I got it. So I say table name is policy and staging record means like how many correct record. So 90 record I will say, base record is 100 I will say, and I will say 10. Like this I will store the data. So this report will be generated and it will be sent through email. Okay. So basically when the data is loaded every day by this Spark job, so we can identify whether like how much data was correct and how much data was wrong. So the wrong data, right, invalid data will go to the error table and the correct data will go to the actual height table. So what we are doing here, how many CSV file will be there? We have to prepare these properties. So what are these property name? Spark.file1. So I'm giving a suffix here, file1, header1, schema1, schema. So one is a file schema, one is a query schema. File schema is saying whatever the columns I'm reading from the CSV file. And query schema I'm specifying the column name in my height table, comma, is data type. Suppose in the policy table I have a policy ID is integer. So I have to say policy ID colon integer type. Like this I have all the columns. Okay. And table you want to insert the data, you have to specify. What is the height table? Okay. When I'm inserting in the error table, so I need the one key value name. Like I just mentioned it. What will be the key value name that I will specify policy. Okay. And any name we can give, it is related to what kind of data it is. It is a policy data, I am keeping it policy. If it is an insurance, I will keep it name as an insurance. Because in the error table, we should come to know one more column will be there, key value. Okay. Just its name. So here I will insert as a key value name is policy. Suppose in the same table, insurance data is going to add. Okay, and its total number, it's how many records? Like 60 is total 70 record, and 10 are the invalid record, and its key value name is insurance. Like this, I will store it. If the number of records, like basically, I can store. Okay, this key value come in here in the error table, not here. Not here. Because error table is common to all the different tables. So how to come to know? So here it will be key value we will be using. So there will be key value we can say this is a policy table. So there we specify the key value. Okay. Any name we can give. Okay. So these are the properties are defined in the property file, and in the driver class we are invoking our service class. Here, this is a driver code. We are invoking the service, and from service class, we are invoking DO class, and this DO class method is it is a running basically a loop basically. So it is running a loop, and basically what is going here, it is just finding the how many total file count is there. Suppose my property file data, I'm reading a property file here, sc.getconf.get, I'm getting all the file count. So if I get this file count 5, So this loop will go 1 to 5. Okay, and then I will read the other property also, like schema I will read. So this is a code, like step by step the code is there. I'm reading the data first, then I'm just doing the validation on top of that. So I'm preparing a single query here. This is the data I'm reading. This is the CSV data we are reading. Read CSV data. This method. And one method I created for finding the valid record. So for valid record, we are having, this is a different data types. So basically we are doing the typecasting here. Okay, if you see here, case when, so this is basically we are doing typecasting. Based on the typecasting, we are identifying the data, if the value comes null after that typecasting, it means the data is invalid. If same data comes after typecasting, then data is valid. Okay, so when we are calling this valid case, so we are calling here valid record. That valid, invalid case, invalid record, valid record. So valid record, here I am matching, I am calling for each column, I am calling this case. So I am checking what is the column name and what is its data type. Okay, based on that I am just identifying the data is valid or not. Okay, so I am preparing the data frame with these two. Okay, I will tell you more in the when I will be starting the start. So this is the project code I am showing you. In this way we can write code and we will create a job. And once we create a job, then we will use a star submit to run a job. Okay. Okay, so now I'm going to tell about remaining Scala concept. Okay. So here, this is the link I found. It is all examples are there. Okay, I'm copying this example in the chat and I will paste in the group. Okay, so basically, what are these examples are there? This is complete Scala examples. So what examples we have already covered? This basic simple example we already covered. We have covered already anonymous function we covered. Higher order function is pending, closure is pending, nested function, recursion is there. Okay, overloading, overriding we covered. Okay, and like something partial function is left. Lambda expression we covered. Where are we already covered? Okay, so these all are related to functions. Okay, next thing is related to string. So whatever operations we do on string, so we have string operations, string concatenation, string builder, regular expression. So those are related to string. And some are the package related things are there. Thing is there. And scalar trait is there. Collections are there. This one is not covered. And each concept we covered this one. Like we covered primary constructor, auxiliary constructor we covered. Polymorphism we covered. And overriding we covered. Typecasting we covered. So those things are covered. Okay. Okay. Let's see like some examples from one by one here. So I just pick up. Okay. One thing is currying is there. Currying function. So what is the currying? So currying is a scala, simply a technique or process for transforming a function. The function takes multiple arguments into a function and that takes a single argument. Okay. So it applies like if I say, suppose I am having an add function which is having the two parameters. So I have created a function plus. So here what I am doing, I am defining, if this is a two parameter function I define. Suppose I have to define for 3. So I have to create another function with 3 parameters. Okay. So what I am doing here, this is the currying function, like basically they're taking a two parameter and it is simply adding and giving a result to the main function. Okay, main, like simply we are just doing the sum. So here we are specifying what it is kind of inline function. Okay, so whatever operation I want to do, I am specifying after the equal. And how to call it? just as a function name and pass the parameter. So I will get the result. Okay. Another way, like this one is one more way. So transforming the function that takes two argument into a function that takes one single argument. Okay. So if I am passing like, okay, so here I am just giving one parameter here 20 and one is 19. So basically I want to do the sum of these two parameters. Okay. So here simply I am calling this add2 function. Okay. So add2 function taking first parameter, then further it is taking second, then it is doing the sum of these two parameters and returning the result. Okay. So here they are saying either this way you can pass it the parameter, first parameter, second parameter, and then operation. Because sometimes, suppose I have total three parameters. Okay. So first I want to do sum of two parameter, then I want to do the sum of the third parameter. So that purpose I can use like this way. Otherwise, if I want to sum all three parameters together, so I can do x plus y plus z. Then I can pass both the parameter, all three parameters together. Okay. So basically, currying is like two ways we can use it. Either we can pass both the whatever number of parameters you want to pass, all the parameters you pass it immediately and get do the operation, or pass one by one. Right. Suppose I have a three parameter, but I want to do sum only for two parameter. Okay. So I will pass the two parameters. Okay, and later I will pass the third parameter. That way it will do the sum. Okay. See, this example is, right now I am just what I am doing. I am only partially I am applying one value 29. But later on, when I am doing sum 5, then I am passing the another parameter and doing the sum. Okay. So here the advantage is like it's kind of partially applied function. Okay. So we can pass the parameter partially. Okay. So these are the different ways we can pass. Like underscore means it's a single parameter. Like partially we can leave it as an underscore and later on we can pass the another parameter. So this is basically calling currying. Okay. So just I run this example. Okay, so this is our class. We create object. But here I am not passing as a partially. If I want to pass it as a partially, so I have to call different way. So I have to this way. So I have to define another function. This is also example of query. I have to pass like this way, and I have to call. This is partially applied function. So result will come same. The only thing is we are passing it as a partially. 29,534. Okay, so that is another way. Other different ways we can do. Like I can pass the underscore also. So I can define like this way. Same function. It is an error. Okay, so this way it is coming the same result. Okay, so next thing is anonymous. So function doesn't have any body, and we can define using the lambda. So using the lambda operator, we can specify. Okay, I think I have done this one. Okay, and another one is higher order function. So a function is called higher order function if it contains another function as a parameter or return a function as an output. So in both the cases, it is higher order function. Okay. So when function is passing another function as a parameter, that is called higher order function. So one good example I found, this is a list we have, and one function is multiply is there, multiply value. So that is doing, it is taking one parameter is the input parameter, and it is doing multiply of 3 in that parameter. If map function always takes each element of the list. Okay, in this list, 3 parameters are there, 3 values are there. So this map function itself is taking a function as a parameter. So this function is a parameter is passed to this map function. So this is called higher order function. So this map function is higher order function. So map function that takes another function as a parameter, so it is called higher order function. So this kind of scenarios is there in the Scala or Python. We have higher order function. So simply I created a list and then I can use it. So here is 3 is multiply of each element of list. So that is final list is 21, 24, 27. Okay, this is higher order function. Okay. So another concept is there in Scala, named argument. So sometimes we are passing two ways we are passing the parameter in the function. One is index, one is name. So when I'm passing a parameter as a name, that is called named parameter or named argument. Okay. And when I'm passing as an index with index, so that is called index parameter. So this is my function definition where I define the function, and this is I'm calling function. So I can specify the, when I'm specifying the parameter name with the value, even the function is defined in a different order, but it will call with the name. Okay, so it doesn't matter whatever the order of the parameter. Okay, so that is called if I am passing the parameter as a name. Okay, so here I am calling this function x comma x equal to 6, y is equal to 8. But here is x is first parameter and y is the second parameter. Even the parameter order is also changed, but it will call with the parameter with the name. Okay, so this is called named argument. Okay, so the advantage is here it will not pass the wrong values. Okay, the same thing is here is first, middle, and last. So it is specifying the parameter name. This is the first parameter named values. Okay. So first is first, then middle, then last. So first, middle, last. Here I am passing last, first, middle, and see what is the output both first part, middle, and last. So all are three coming same, right? All three are coming same. So either I can call it like this way without any name. Then whatever is the parameter name is there, it will call that. If I am specifying the name, it will automatically copy on that name. If I am providing with a different order also, it will not matter. In that case also it will copy with the name. Last will copy to last, first will copy to first, middle will copy to middle. Like this it will call. Okay, this is a named argument. Okay. This I will tell later. Nested function. Function inside. When we are calling, one function is calling another function. So that is called nested function. So this is a max and min function is there, A and B. So I am checking if A is greater than B, then it is a max value. And if A is less than B, that is a min value. Okay. So two functions I created. One is max value function, max and min value. So max and min value basically depending on the variable. I am just if it is calculating the value. Okay. So what I am doing here, max and min value, both function I am calling and I am getting the result accordingly. Okay. So max value, the max value will come, min value function, min value will come. So one function having two nested function. Okay. So I am just calling two inner functions. These two functions will call and it will return the result to the outer function. Okay. Multiple nested function. See, one function is defined from here. It is starting from here. Again, the other function is calling here, and third nested function is calling here. So first function is printing the value geeks, then second is printing GFG, and third is printing the geeks for geek. So this function inside function is calling and it is printing the value. So nested functions also we can call. So once first function is called what? Fun. Fun is calling geeks, geeks is calling GFG, GFG is calling this, and accordingly is coming. Okay, like this. This is clear. This one nested function. Okay, recursion, parameter nest method, and recursion. Recursion meaning like when the function call itself, that is called recursion, right? So recursion, like we can use factorial or we can use GCD. Okay. So this kind of functions we can write using the recursion. Okay. So factorial, it's a very simple factorial function. So basically, factorial is like if I am calculating the factorial of 5. So what will be the calculation? So 5 into 4 into 3 into 2 into 1. Okay. So when I am calculating the factorial, so basically I am calculating here factorial of 3. So when 3 is passed there, I am checking if it is n equal 1, then it will be returning 1. I mean, this is right now it's not 1, it is 3. So 3 into factorial of 2. So 3 multiply of factorial 2. Again factorial 2 is called, it is not still 1, then it is now 3 into 2 into factorial of n minus 1. 2 minus 1 is 1. Again 2 minus 1 is 1 is, does n equal to 1. So final result will be 3 into 2 into 1 and that will be 6. Okay. So that is called recursion. Okay. This is same like in Java, recursion is there, like GCD. So greatest common divisor. Calculate GCD of two numbers like 12 and 18. Okay. So this one is like also using the factorial we are calling. No, using the recursion we are calling. Okay. Like sum of all the numbers. So I have to calculate the sum up to 10 number. Okay, I just pass the number and I want the sum of all its digits, right? Like 1, 2, 3, 4, 5 up to 10. Okay, like I'm passing here 55. So what I'm doing here, same thing like factorial way I'm checking it. If factorial like sum 55 I'm passing. If num equal to 1, I will return 1. Otherwise, I will be calculating like this way. Sum of 55 minus 1 plus that number 55. So it will be sum of 54 plus 55. It will be calculated and it will do the sum of 55, 54, 53, 52. So then it will get the result 1540. Okay. So what is a tail recursion? Okay, this thing is not in the Java. Okay, so simple recursion is there in the Java, but tail recursion is not there. So tail recursion function is considered better than the non-tail recursive function. And this is called tail recursive because it is call is the last thing done by the function. Okay, so here we have to use this keyword annotation at the rate tail recursion. Okay, factorial we can call it tail recursion. So there is no need to keep record of the previous state. So tail recursion will automatically start and finding the last operation done by the itself. Okay, just understand here. Suppose I am calling a factorial of 5. So when I am passing is here factorial 5. So it is what is doing here? What is ACC? Okay, two variables I have declared here. One is ACC and one is n variable. Okay, so what we're doing is here, if n is less than equal to 1, I am returning this ACC. Otherwise, okay, so basically what I'm doing here, factorial ACC I'm calling. So initial value 1 I'm passing as a ACC. Okay, so this ACC value I'm passing 1 and n value will be whatever of the factorial. So I'm checking here, same factorial ACC I'm calling again ACC. So ACC value will be 1 initially and comma n minus 1. So this tail recursion function is calling. Initially the factorial is called. When we are calling this factorial inside the function, we are calling the tail recursion. But here on the top, the function is itself a tail recursion, right? I am calling this GCD. This GCD function is a tail recursion function. Well, this is a normal recursion function. This function is a recursion function, factorial. But here, tail recursion is inside the normal function. So I am passing the 5 value here in the factorial. Inside the factorial, I am calling this tail recursion. So here I am applying the tail recursion. So I have to tell which part I want to make the tail recursion. So the logic I need to write in this nested function, in this tail recursion function. So here I have to use this keyword at the rate tail recursion. Okay, if we apply directly on the main factorial function as a tail recursion, it will give the error. If we use this annotation and our algorithm is not a tail recursive, the compiler will complain. For instance, if we attempt to use this annotation on the our example factorial method, we will get the following compilation error. So basically, I have to define the tail recursion within the function itself. So as a nested function, another function we have to create, and there I have to define the tail recursion like this. Overloading, overriding is covered. Okay. Lambda variable argument, this one is covered. Okay. Call a method on a superclass in a Scala. So this is kind of superclass constructor, superclass method we want to call, okay, from the child class. So this concept is how to call the superclass method. So in the overriding, we use super keyword in Java. So same is super keyword is here to call the base class method. Okay. So suppose I have a one class is here, and this is having two functions. One is read and one is write, and I'm extending this class here, and I want to have a one function is here, read then write. So I need to tell here, first I want to call read and then I want to call the write of the superclass. Okay. So basically what I need to do, I need to use super.read. So super.read means superclass function will call first. Okay. So here I am telling the order, like which order I want to call. So I will use super.read and super.write. Okay. So this is a way like super keyword we use to call the superclass, the parent class function. Okay. So that I can call, and it is possible only in inheritance, like when we are inheriting the one class to another class. So this is a child class and this is a parent class. Scala the repeated method parameter. So in Scala, repeated method parameter are supported, which is helpful. We don't know the number of argument a method requires. This is, I think this is a where argument only. Like int star we are using, so we can use the number of parameter. Okay, now I'm going to tell about some collections one. Okay, so how to use collections. So these are the different types of collections are there. We have list is there, list buffer is there, list set is there, scala array is there, and array buffer is there. List buffer same way, array buffer is there, and we have tuple is there. Like when different data types values, that is called tuple. And set is when you want to keep it unique values, that is set is there. Bit set is something is there, okay. And hash set is for the unique values. Stack is there, like we can stack is we have push and pop operations are there. Like we will insert the element. So whatever element is on the top, that will be retrieved first. That is called stack. Okay. The same is in Java also. Hash map is for key value pair. So these are the different collections are there. So list. So simple list is there. Like I can create a list using the list keyword. So variable name equal to list, and then I can specify the parameter. So I can create a parameter of the list. Like suppose if I want to create a string list, so I can give the value as a double quote value. So this is a list of string type. This is a list of string type. So I am creating a two list here, and I want to print the list. So I can I can iterate the element of the list. So what is the way? One is this list is printing the object. It will print the object. Okay. So basically what I'm doing here, I'm just taking each element of the list and I'm printing it. Basically this list element has a string. So in this for loop, so it will take one by one each element and it will print this each element. Okay, and this list is directly printing the list. Okay, without for loop, I can print the element of the list. Okay, so this way, but this list will be printing like the object type. Okay, so see the difference in these two print. This print is I'm iterating with the for loop and I'm printing the value, but this list is as it is printing like this. List of like this element is printing. Okay, so like an object is printing. I'm just running this. So like an object way it is printing, list of this one. So if I want to use as an individual parameter of the list, I have to use to iterate. Okay, and just display purpose I want to show what are the elements in the list, I can use this way also. Okay, just I need to show what are the elements are there in the list, whatever list I have created. Okay. So what other way of the iteration of the list? So like some empty list I want to create, I will create like this bracket, empty list. If I want to create a list inside list, so I can have list and list of list. So I will be defining the parameter values is the int type. Okay. And this list type is list of integer type. Okay. So this is a 2-dimension list. So when I'm printing this list object to the list, I will print it like this. I will get like this list of list value, I will get it. Okay. What other operation I can do? Suppose I do list or head. So return head of the list. So I will get the head value of the list is C. That is the first element. Tail I do, last element I will get it. Okay. No, tail I will get it. All the other element, remaining other elements other than the head, I will get as a tail elements. So tail will be remaining element. This is a tail. So suppose I want to get only first element. So I will use list or head. Okay. And last element, if I want to get, I can use the iteration and I can get the last element. Okay. If I want to check list is empty or not, so is empty function is there. So list dot is empty, it will tell me whether list is empty or not. Okay, just like a Java, we have empty. List dot fill. So I used to create a uniform list in Scala. So I want to fill the list, right? So any empty list, I want to add more element. So I can repeat 2, 2 10 times. So like basically I can 8 and 4. So 8 times 4 is there. So like this, which element I want to fill. Okay. So here 3 scala. So 3 is a number. 3 times scala will come. So that is coming. Reverse list, simple reverse function is there. So it will reverse the list. 5, 4, 3, 2, 1. So that is reverse is coming. Okay. So these are the all collections. So similar functions will be there in the other collections also. Like set is there. Okay. So list buffer. So list is collection which contains immutable data, means it cannot be changed. But if I create a list buffer, it is a mutable data. Like I can change this. A list is immutable. If we need to create a list, changing. Okay, if I want to change even, then I should use a list buffer. Okay, so list buffer, when I create a list buffer type, I can change it. I can modify the element in the list. Okay, so see here, like list buffer I created. So I am adding the element one by one. Okay, name equal to name plus this element. Name plus name equal to like this I am adding. If I want to access any element, so through index I can access like 1, 2, 3. So I can access the element. Like if I access the element in the my list of 1, println my list of 1. It is coming first element. So whatever list operation you do or buffer list, both are same. See here only first element is coming. List of 3 I give, third element will come. So like this we can print the element. Okay. So index basis we can access the element from the list, whether it's a list or list buffer. Okay. The only thing is we can add the element, we can append the element, we can do in the list buffer. Okay. So we have the append method is there. We try it this one in list. Okay. So I'm giving their name is my list. My list. It is giving an error, right? Reassignment to val. Okay. If I make it var type, error is coming, right? Because in the list we can't do it. Okay. But if I do the same thing with the list buffer, so it will not give the error. Okay, if I use list buffer, so alt enter. Now so list buffer, these elements are added. Initially list buffer, I added this element, then I added 2 more elements, then I append. So these are the 2 ways. Like using append method is deprecated, but plus equal method is still there. So this method is deprecated, but it is still working. So total how many element is added in list buffer? 1, 2, 3, 4, 5. So this is the use of the list buffer. So when you want to do any like a mutable list, so we will use it list buffer. Okay, and even the remove the element from the list also. Deleting the list buffer, we can delete the we can remove the element, and we can tell about in the indexes also. Particular index we want to remove 1, 2, 3, so we can remove that also. 1, 2, 3 class scala and article. Okay. Okay, and 0 if I say only 0, then index if I give, only number I give, it will remove that particular index. So 0 index is removed. Then it 2, 3, so first, second, third. Now it becomes 0 after deleting this. So 0, 1, 2, 3, so 1, 2, 3 will be deleted. Okay. List set. So similar like set is there in the Scala, list set in the Scala. Okay, similar functionality, same like, but only thing is it can allow the unique element. Okay, so everything will be the same. Whatever is the list buffer, same like a list set. And Scala arrays. Arrays is similar type in Java. Like it length is fixed, we can't grow it. So one dimension array or multi-dimension array is there. Okay. So this is array, like using the array keyword we use, and same for loop we can print the array values. Okay. So we can create an array and we can iterate an array using the for loop. Okay. So we can simple array we declare and we assign the array, and we can print the array. So using arrow operator, we assign the value in the variable and we will print that value. So all the values in the array is printing. This is a iteration we are doing. This is we are iterating the array element. But other operation like we can do in array also. So accessing the array using the index value. Through indexes we can access the element in array. If I want to assign the value in the array, updating the value in array, we can update like based on the index, we can update. Adding element in array, we can add the element in the array, new element. Concatenating two arrays, like though two arrays I want to do, so concat function is there. So we can create a new third array. Okay, so we can concatenation, we can do. So array is a fixed size data structure, store the element in the same data type. The only thing is here is a homogeneous data type. So whatever the data type is a one element, the same data type will be for the other elements in the array. So we can use the array with the same data type. So data type is same for all the elements in the array. And what is a tuple? Tuple is basically the different data type value we can return by using tuple. Suppose one tuple I create, like I have a one integer, one string, and one boolean. Okay, this is called a tuple. This variable is called tuple. And now this tuple, it is a different data types value is returning in a single object. Okay, that is called tuple is a collection of elements. Tuple are the heterogeneous data type. So instead of the like now this it contrasts to array, the difference is the array contains only same data type, but tuple is containing the different data types. So here, if I want to print each element of a tuple, I have to use underscore 1, 2, 3 like this. So it will access. Okay, so I have to give the object name, variable name, dot underscore 1, underscore 2, underscore 3. Like this way I can access the element. Okay. Or I can define like three variable like this. Like here I define one variable name. So I am using the index parameter underscore 1, underscore 2. But if I am defining the three parameter, automatically A will be going to the 15, B this name, and C will be going to this boolean value. Then you can print all three different values. So these are the two different pattern. One pattern is you can define individual parameter that will take it their separate value, or you can take it in a one value variable, and then you can use index parameter to take the individual value. Okay. If I want to iterate the tuple, I have to use like this. So there is a for each loop is there. So I have to use for each I println I. So this I can iterate the tuple values, because these are all different data types. So I'm using product iterator dot for each. Okay, this way I can iterate it. Okay, and all the values I want to convert in the string, so toString method I can use. Okay, so it will convert toString when I call it. So it will be giving me the value as a string type. This tuple is a string. Okay. Swapping is a one function which can interchange the value. Okay. Okay, so remaining things I will do tomorrow. With all remaining things you can do practice, like whatever things you can find, like just simple examples are there. Just try to do practice. Okay. Any question?
No.
Okay. So this link I'll already share. Okay, just practice on this link. Like just set up first IntelliJ to run the Scala code or Scala programs, so that you can practice these different concepts. Okay. Yeah.
Okay.
Yeah. Fine.
Okay.